Hello everyone. In this video, we will continue to examine topic D.2, stellar characteristics and stellar evolution. In particular, we will examine high mass stellar evolution. Recall that for low mass stars, that is for stars less than 8 solar masses, as defined by the IB, those stars end after fusing helium in their core and then ultimately shell fusion with an inert carbon and oxygen core that ends up becoming a white dwarf. They are simply not big enough to fuse carbon and oxygen. For stars greater than about 8 solar masses, that is not the case. Uh, Stars bigger than about 8 solar masses can undergo carbon and oxygen fusion, and in fact undergo carbon, neon, oxygen, and silicon core fusion. So they fuse a succession of different elements. You do not need to memorize them, um, but you should certainly know that the very largest stars can fuse all the elements that are possible to fuse. This ends, however, with a non-fusing iron core, and we'll discuss why in a moment. Uh, in this process, the stars sort of get bigger and smaller and bigger and smaller again in a manner reminiscent of the horizontal giant branch and the asymptotic giant branch as they oscillate between a core fusion state where they're a little bit smaller over here, say, and a shell fusion state where they're over here. And the true description of this is actually quite complex. The sequence is a little bit tricky, but suffice it to say that the stars sort of breathe in and out. They are very large the whole time, but at their very largest, they are the largest stars in existence. A supergiant red star um, undergoing shell fusion can be the size of Jupiter's orbit. So Earth would be well inside this depicted orbit here. And that tiny, tiny core at the center has all of the elements undergoing fusion. Now, this process ends with a non-fusing iron core, and the reason for that is fundamentally related to the binding energy curve. Recall that iron is the element, iron 56 along with nickel 61, are the elements for which fusion no longer produces energy. Any elements heavier than that, you actually get energy out when you break them apart. And as a result, this process ends with an iron core. One thing to note is that the duration of these stages gets exponentially shorter. So hydrogen fusion, or the main sequence, takes place over roughly 7 times 10 to the 6th years for a 25 solar mass star. Note, it's a very large star. Um, Whereas the carbon, neon, and oxygen fusion stages that we just discussed take less than 1,000 years. It progresses from oxygen fusion to silicon fusion in the course of a single day. And that is an amazing fact. So it happens on astronomical timescales in the blink of an eye. And this ends with, as I said, that non-fusing iron core.